So you've already taken a look at this FRQ, and you should have noticed a couple of things, that we have the time in minutes and the temperature in degrees Celsius, and so we don't have a rate here. This is just going to be the temperature at any time t, so we have some raw data. So it says 0 to 10 minutes, and the values of h of t are just shown in the table. So part A says use the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. So there's some clues for you. It wants h prime of 3.5, right? This is for A. And so, which is the average. You don't have the derivative, right? And so you need, basically it wants the instantaneous rate of change at 3.5. And how do you do that? If you have raw data, this is when you use the average rate of change. Okay, because remember, this is a slope, average rate of change. So that's equal to, and then write this out because this could be worth points. H at 5, so you're going to go one above it and one below it, right? H of 5 minus H of 2 over 5 minus 2, which is 52 minus 60 over 3, which is negative 8/3, and use your minutes. This is a rate, so this would be degrees Celsius per minute. Okay, now, if it's a calculator problem, so if you use your calculator, it'd be negative 2.667 degrees Celsius per minute. Now, it just asks for the temperature that it's changing, so you need to use the negative, okay? So that would be part A, and that was worth 1 point. And the 1 point was the answer with units. Okay, so with units. All right, let's go on to part B. All right, part B says using correct units. Okay, so that means we better use the units. Explain. And guys, on the AP exam, this is how they're going to be doing. They're going to have a lot of explain stuff because you got to show what you know. And they got to make sure you're not like just plugging in numbers and kind of looking stuff up. So here we have 1 over 10 of the integral 0 to 10 ht in the context of the problem. So what is this 1 over 10 mean? This is the 0 to 10 would give you the temperature at time 10, but 1 over 10 in front of it means this is the average value. So you got to use the word average when you say that. So obviously you're not going to write average value. You're going to write out what it is. But I'm trying to talk to you about it. So you would say 1 over 10 of the integral of 0 to 10 of h of t dt is equal to, or just say is since you're using it, is the average temperature, and now it wants units, so say in degrees Celsius of the t for time 0 to t to 10, between 0 and 10 minutes. There, you've used your units. Okay, so how do the points add up for this? This one is worth 3 points. So all that is worth 3 points. No, yeah, I didn't answer the second part. So, okay. The meaning gives you 1 point. So that right there gives you 1 point. B goes on, to say use a trapezoidal sum. Okay. Trapezoidal sum with 4 subintervals to estimate. And here I'll just tell you, don't forget to use the 1 over 10. Don't get it wrong because of that. So I would write the trapezoidal sum approximation is equal to 1 over 10, the integral, no, we're not going to use the integral of, and then the trapezoidal sum would be, see how I wrote that 1 time? 1/2, now you can pull the 1/2 out, but I like to see the whole trapezoid. So this would be, first let's get our distances. 0 to 2, 2 to 5 is 3. I bet messed that up. 0 to 2 is 2. 2 to 5 is 3. 5 to 9 is 4. And 9 to 1 is 10. So we have those. So it would be 66 plus 60 times the width, which would be 2, plus 1/2 of 60 plus 52 times the next width, which would be 3, plus 1/2 of 52 plus 44 times the width, which is 4, plus 1/2 of 44 plus 43 times the width of 1. Now let you use your calculator, and the only thing I'll say is you should calculate it twice, okay? Because this is a simple problem. You don't want to get it wrong because you punch something in the calculator wrong. So you should get, 1/10 times 529.5. So it's approximately equal to 52.950 degrees Celsius. So that's the average temperature. And does that make sense? Always go back and look up. And it's definitely going down, but 52 could be like right in the middle of the average. So this answer does make sense. So let's see how you got your other 2 points. So there was another point giving you for doing a trapezoidal sum. So writing it out gets you a point. Do not just punch it in the calculator. And 1 point for the correct answer. So those were your 3 points for part B. Let's go on to part C. Evaluate 0 to 10 of h prime of t using correct units. Explain the meaning of the expression. All right, so we have the integral of the derivative, which this is the fundamental theorem calculus, isn't it? 0 to 10 of the derivative is just equal to h of 10 minus h of 0. So this is really important that you remember this. And so let's do it. That would be h of 10 is 43 minus 66. So you get negative 23 degrees Celsius. Now that's an answer, but then it says, what does it mean? And this is over the long haul, the temperature dropped by 23 degrees Celsius after 10 minutes. All right, so that was C, and C is worth 2 points. You get 1 point for the negative 23 and 1 point for saying what 0 to 10 of h prime of t dt is. Now, if you didn't remember that's what that is, remember it now, okay? That's why we're practicing. You'll see more of these. I feel like this question is really good because I see this being on the test. So, of course, then they give you a function, okay? They say, oh, then we got biscuits, and they start out temperature 100, so we have an initial amount. Make sure you see that. That wasn't given there for nothing. And they were removed from the oven. The temperature of biscuits is modeled by this function, b prime of t, well, and then a function where the derivative is negative 13.84, blah, blah, blah. Using the given model at time t equals 10, how much cooler are the biscuits than the tea? So this is asking you, what's the temperature of the biscuits at time 10? So you basically want the starting amount, right? 100, and then how much cooler did they get? So if we're going to write this out, we want b of t, right? And I want b of 10. I want the temperature of these biscuits after 10 minutes. See, if you write this stuff out, it makes sense. That's going to be equal to b of 0, here's our fundamental theorem of calculus, plus the integral from 0 to 10 of b prime of t dt. And so you know what, you're going to have to use your math calculator, but that's equal to 100 plus, and then you would put that into your calculator, and let's see, I just did it together, so 100 plus, I'll just put 0 to 10 of b prime of t dt, and that's equal to 34.183 degrees. Now, that's what time they were at 10, so they want the difference. They asked for the difference, so you have to find, well, what was the T? The T was 40, so it's the temperature of the T minus, wait, that's H, right? The temperature of the T, so H of 10 minus B of 10, which is 43 degrees minus 34.183 degrees, which equals 8.817 degrees cooler. Okay, so that was D. Sorry, I squeezed that in. So D was worth 3 points. This is worth C was worth 2 points. The first thing you got a point was if you wrote this integral out, including the b of 0. The second point was for using 100. And the third point was having the right answer. All right, so that was FRQ 310.